So welcome to this course, Internet of Things, and I'm your instructor. We'll be covering this course in about 30 to 32 lectures. And this course is, as you know, is an interdisciplinary course which involves a lot of concepts, and there are a number of ways in which this course can be covered. We will take a more practical view of this course so that you are able to have both the conceptual as well as an implementation based understanding of this topic. So let us begin with, this is the outline for today's lecture, and today will be basically an introduction to this topic called Internet of Things. I assume that all of you have already registered yourself on Google Classroom. That is the place through which we will be interacting. All announcements, all links related to examination, assignment, etc. will be through this Google Classroom. In addition, there's a course website where you will be provided different materials time to time. All the video lectures, etc. will be uploaded there. So you should keep yourself updated. Have a look at the course website regularly, as well as all the announcements that are posted on Google Classroom. Okay, now coming back to today's lecture, this is the broad outline of today's lecture. I will introduce you to the concept of Internet of Things. We'll talk about some very, very basic concepts so that you get to know what exactly is this thing called IoT. We'll see different application areas of IoT through different videos. And today we'll mainly be watching a lot of videos. So we'll see some application areas, and whenever a topic and this kind of topic is taught, it's very important to know how did this topic, why did this topic become important today? And for that, we need to know the history and how things have progressed so that we have reached today to a place where this Internet of Things is actually become a course and students are interested to take this course. So what is the history behind this? So we'll look at a very basic idea of the IoT ecosystem, which will give us an idea what exactly is and how do you build an IoT system? What is the IoT architecture? We'll look at the hardware as well as the software side when we talk about the IoT architecture. And then, as I told you, we'll try to answer to the questions that why is IoT becoming popular day by day? What has made IoT so popular? And all the concepts that you will see were already there from 60s to 70s. So what has happened that has brought into IoT at the limelight? We'll try to look at the reasons for that. And then I'll take you a very quick overview of the course content. I'll give you the summary of the entire course, where I'll talk about the 5 modules that we have in this course. And I'll give you a big picture view of each of the module so that you get to know what exactly you will get in this particular course. And finally, I'll also today talk about some of the advanced topics and some challenges that we encountered, or the research directions of IoT, because as you know that when a topic progresses and it is there for almost a decade, there are different challenges that come up each day, and the researchers are trying to find out solutions to that. There are quite a few publications that are focused towards this particular area. One of them is the IEEE Internet of Things Journal, which is one of the premier journals which publishes articles related to topics on IoT. Some of the topics on mobile computing also are related, and we have a journal called IEEE Transactions on Mobile Computing, which also publishes articles related to IoT. And today, with this pandemic situation that we are in, there are a lot of implementations which have been proposed, presented, which tries to utilize IoT to help us overcome this particular situation. So this is the broad outline of today's lecture. Let's begin this topic with the very fundamental question. What is this? What is IoT? Well, if I answer this question in one word, it's like a lot of objects connected to the internet. Okay, this is how I will be defining in one line. Internet of Things. So things or objects which are connected to the internet. Okay, this is what Wikipedia also says. So we have a lot of physical objects which we are calling as things, and they are connected to the internet. Well, you may wonder, why do we need to connect all these things to the internet? Before this era, or before this IoT era, we had connectivity of computers. Why did we connect computers? Simple reason was that computers are meant to do some computation. But it often happens that one computer has only a limited resource. It only has a small computing power. It has a small memory. Storage capacity is also limited. So with that restricted resources, a single computer often is not able to do all kinds of tasks. So what happened is, we tried to introduce the concept of parallelism, where we tried to use many computers to solve a particular task. And for that to happen, all the computers need to be connected. Why? Because when all of them work together, they need to talk to each other. They need to interact. So computers had to be connected. And hence we have the connectivity of computers. And then there was, an entire subject which was devoted for that. We understood how computers can be connected, how computers would be transferring data, and the entire protocol stack was developed. The same thing happens to these objects as well. The objects that we are referring to as things, if they are handling data, we want these things to interact among themselves. That means they would like to exchange data. What is the idea behind exchanging data? The exchanging data is mainly for two purposes. One, to collaborate and solve some particular task. And two, to provide some information out of the raw data, which we call data analytics. So these things would give us a data. And then we would be trying to find out some or extract some useful information from the data. This is the primary concern of things exchanging data among themselves. So one way to connect these things is through internet, because it's already an established connectivity. So things would be connecting to the internet, and that is what we call Internet of Things. Well, this Internet of Things that you create is actually connecting people to people. That can be one connectivity. It can be connecting people to machines. So we have a people to people connection. We have a people to machine connection. And we have a machine to machine connection. So these are the three connections that we introduce when we connect things to the internet. And if you look at a very simplistic view of this entire IoT ecosystem, what you find is there are things, as you look at this diagram on the right hand side, you have things which are nothing but objects. We call them smart objects. Why smart objects? Because they are objects that can gather data, they can collect data. And at the same time, there are objects which can be instructed to do something. Okay. So these smart objects, they are used by people according to their own way. And this data that they obtain is stored somewhere which we call the cloud. So the basic three things that connect and create this Internet of Things is smart objects called things, people who are the users of this. Users of what? Users of the things. And how do they use that? They make use of some service provider, which we call the cloud service provider. What is this cloud service provider? It's a very high resourceful infrastructure provided by some third party. Okay. So it is like this that you find, you take example of your mobile phone. You want to call to your friend. So the mobile that you are using is the thing. You are the user and you are making use of some services which is provided by your service provider, the mobile service provider, whoever it is. And that is the third party service provider that is providing you the connectivity. And you get connected to your friend with whom you are making a call. It's very similar to this, except that it's not mere a mobile, it is any device that gets connected. This is overall the picture of Internet of Things. Well, so with this, let's look at the different applications. Okay. And I'm going to show you a video. Just, are you able to view the screen and the audio? Can you just tell me the audio as well?
Yes, sir. No audio, sir.
No audio? Okay. If you are not able to view that, I have provided the link on the course website, the second link on the course website. All of you, I would suggest, in case you're not able to listen to that, please click on that. And in case you are able to hear it, this is, so I'm playing the video. Please have a look.
We have all heard of the term Internet of Things, or IoT. As it is becoming an increasingly growing topic of conversation, let's try and understand what exactly is Internet of Things. You may be watching this video on your PC or phone, and it is connected to the Internet. Internet on your device could be connected through broadband or Wi-Fi. Simply put, this is the concept of basically connecting any device with an on-off switch to the Internet. There is people-to-people connection, there is people-to-machine connection, and then we have machine-to-machine connection. Internet of Things, or IoT, refers to billions of physical devices around the world that are now connected to the Internet, collecting and sharing data. As the price of processors and wireless networks go down, technology is becoming cheap and penetration of smartphones are skyrocketing. It has become possible to turn anything into a part of the Internet of Things. It is like adding a level of digital intelligence to the devices that would allow them to communicate with a human being or with another machine. And that's not all. According to reports, there would be more than 26 billion connected devices by 2020. That's a lot of connections, isn't it? But why on earth do we need so many connected devices? Let's take another example. Mike has to go for a morning meeting. His alarm clock wakes him up at 7 a.m. and notifies the coffee maker to start brewing coffee. When he goes to take a shower, the geyser was already notified and warm water was available for Mike, saving his time. Mike's car is connected to his calendar and tells him to take the best route to avoid traffic. If the traffic is heavy, his car might send a text to another party notifying them that Mike will be late. The Internet of Things can be applied to transportation, production, smart cities, and many other projects, saving us energy, time, and reducing waste. We are yet to completely understand how Internet of Things will impact our lives. What would be the opportunities and challenges that will come with it? For now, the best thing that we can do is to educate ourselves about Internet of Things, because IoT storm is here to stay, and the new rule of the future is going to be anything that can be connected will be connected.
Well, so did you watch that? Were you able to hear the audio or no? Okay. So what I intended was to show you the power of IoT. What exactly is the different application areas of IoT? You're already aware of that. It was just to give you a view of how IoT has penetrated into everything today. Okay, because we know that internet today is everywhere and we are living with that every moment. And so if devices are getting connected to internet, that's what is IoT. Well, so the first and the most common, the most common application of Internet of Things is in the domain of smart home. What exactly is the idea behind this? Anyone? Are you aware of this particular concept called smart home? Have you heard of this term? You must have.
Yes, sir.
What yeah, can you tell me anything about this? Any idea?
To control the devices in our home with the help of internet or any smart gadget.
Yes, to some extent, yes. So the idea is that smart home means what is smart home actually? You are intending to use your electrical and electronic appliances in an intelligent way that would give you a better living. I have shared with you a link, the first link on the course website. Have a look at that, which shows you how our living, day-to-day living has changed by introduction of different electrical gadgets that we are surrounded with. So the idea is that if you are having a lot of electrical and electronic equipments in your home, how can you make use of them so that they can be used in an intelligent way that will help your living, that will make your living more healthier, smoother? So one idea is that whatever appliances that you have here, as you can see in this picture, what we are talking about is all the different things that we use in our daily life, that is at our place. Whether it is, if you are in your room where you have different lights which are connected. Now you can utilize these lights to be turned on and off in an intelligent way. How? Suppose if no one is there, no one is occupying a particular room, there is no reason that the lights should be turned on, because if you turn on the lights, it is unnecessary wasting a lot of energy. So can you do something by which the light would automatically understand that there is no one occupying the room and would be turned off? So it's like a button that turns on and off depending on some data that you have obtained. What is the data? That there is no one occupying the room. So this lighting that you are doing is a smart lighting, and you are making use of some devices to gather some information and accordingly turn that off. So you gather some information, that is, you sense some information, and you actuate something, that is, you control that. How? The data that you sense is sensed or is obtained and stored at some place, and there is some computation or some some check that is done, and accordingly some information is sent back to the light that should be turned off. This is what we call smartness or intelligence that you put in this particular lighting. It's nothing very fancy in it. Just that you record something, some physical information, and accordingly you send some information back to that particular device that it has to be worked, or it has to work in this particular way. This is what is smartness. Whether you are talking about the AC, where you are recording the temperature, right? So you are recording the temperature and accordingly you are sending an on-off signal. That's what we are mentioning. So there is a thermostat that is recording the temperature of your room, and it's after it records, it sends it to some recording, some storage or some computation unit, and it is sending back an on-off signal. That is again same thing for the curtains. If you are making smart curtains, which again wants you to turn that remote, turn it on or off depending on your information, and no one is occupying. Okay, so you have to turn it off. When someone is occupying, you want to allow light to enter, so the blinds will be turned off or turned on. That means they will move up. So all this security camera, again, this is very interesting for surveillance purposes. Whether you would like to know whether someone has or would like to enter this particular house, whether you would be allowing that person to enter or not. Then we have TV speakers, which are again to be controlled depending on what and how, what is the state that in which you want this particular thing to be. Locks, which will again be automated depending on whether some person who would like to enter or not, for that things will be locked. Different kind of appliances. Irrigation, the park surrounding this particular compound, or in this particular compound, you want to grow some plants. So you would like to know what is the state of that particular soil, what is the humidity, what is the pollution. So all that can be recorded and information can be passed on or stored somewhere. And once you get that information, you try to extract some information from that data and try to send the notifications to that particular user that this is the state of the soil, this is the state of the water content or the humidity. So it is not a good time to sow these kind of seeds or to grow these kind of plants. So you would not be able to do that. So it actually saves you time, it saves your energy. That's it. So it's like gathering some data, sending those notifications, and from that, doing some computation and sending notifications. And accordingly, the user of that particular device or whoever is intending to do something would be able to take a decision whether I should do it or not. Okay. This is the basic idea of smart home. It improves our living. That's all. Well, the next thing that we have is second application, smart grid. Have you heard of this term? Smart grid? Anyone who's aware of this term? No? Well, let me give you an idea. You are aware of this electrical connections that reach your home, right? The different power lines that give us the electricity. And all of us know how power is generated. On the left-hand side of this figure, you see on the ones that are shown in purple, this is what used to happen yesterday. And the first one, this one, this is the way in which previously power used to be generated. Power is usually generated by large power plants. They are either thermally generated or hydroelectric power plants. So the power plants are mostly installed either by government or by some very some private sectors, and they are the ones that are generating power. So this is the production that they bring out. So the power that they generate are mostly national, controlled nationally. So the government decides how this power will be distributed. We have state electricity board that obtains this power from these power plants and distributes that. And for the distribution, it provides different stations where it has different power lines. It builds different power grids, and it uses different transmission lines for sending these power to the ones who would like to use them. Who would like to use them? Well, they are the consumers, we, right? So what we do is we obtain this power, which is provided by the government agencies or by some private sectors, and we have to pay. So this is like an utility. You pay per utility, and your contribution is only in the payment. So the amount of electricity that you consume, you have to pay for that. And the problem is that these people have no role in this entire power generation to execution to the power usage. Consumers have no role. And when I say no role, I mean there are a lot of times, you would like an efficient power distribution, which is not possible. You may like to have some kind of a smart meters where I would like to distribute my power. I would like to have, depending on my usage, I will be requiring to draw some amount of power, okay, the required power. So can we have a system where the users would also participate in this entire process? And for that, we have on the right hand side, which is the idea of smart grid, where we have the power sources are not only the very high large power systems, they can be very middle level generation units such as solar power or the biodegradable power. They can also be utilized, powers through windmills. They can also be a very useful source of energy. So once you obtain that, so the power generated from all of these sources, not necessarily only very large hydroelectric or thermal plants, wind energy, biodegradable energy, solar power, all. And the second is, even the market has to be decentralized. There would not be any central nodal agency or government agency that will be controlling everything. It will be decentralized. Many people who will be able to provide these power. How? Obviously, there will be small scale transmission only through regional supply. So if you are in a particular locality of your country, there will be some power producer and some power transmitter that will be providing you to only a small region. So that will be a useful way to reduce the cost, as well as you will be making things decentralized. And most importantly, there will be active participation of the consumers in the system. This is very important. On the right hand side, you see this is the basic idea of a smart grid, where you have it's a real-time dynamic network of electrical demand, supply, and control. Very, very important. So it's a system that is built based on the demand and supply. It's not that I don't need it, but still I have to consume it. It's not like that way. Okay, whether you like it or not, you have to pay this amount of electricity bill. No, I won't. I would be preferring something for which I have consumed. And for that, you need to make things smart. Okay, here you have an industrial plant, right? And interestingly, what happens is, so the industrial plant is generating the power, but it's not distributed by a central agency, but it is distributed in a grid. Okay, what is this grid? It's kind of a network that you have built. Anybody who's generating some power would be putting its power to that particular storage or this network. And anyone who wants it will be drawing it from that particular grid. So it's not like a dedicated connection that is coming from some substation to you. No, it's not like that way. It will be dedicated to a grid, and that grid will be providing you your power. Okay. So again, I would like to share with you a video where I'll be showing you the smart grid.
In India, there are 800 million people who lack access to modern energy. energy from the wind and the sun offer new opportunities. How can we use these energy sources to tackle the problem of energy poverty? So more than 800 million people, and they use sources like wood, charcoal, and oil lamps. And this often goes along with health problems, with fewer opportunities for doing business, and for children with difficulties to study in the evening or at night. The current solutions to energy access struggle to meet the rising and diverse demand in Indian villages. Smart grids are seen as a solution to this problem. Smart grids are energy networks that align the demand and supply of energy by using ICT. ICTs help to distribute the available electricity to where it's needed. Our project is about developing and implementing smart grids in rural India. And we do this together with an interdisciplinary and international team, both from academia and from the private sector. This interdisciplinary team because questions around smart grid development go beyond the technical. For example, there are many sociological questions.
So what happens when you introduce a new technology in a village environment? Does everyone get equitable access to it? Does everyone derive equal benefits from it? A growing body of research says that issues of power, politics, and gender are important in understanding and resolving these issues. For example, some people in the villages are socially, politically, and economically stronger than the others. These people often get control of the energy access infrastructure. This makes it difficult for other weaker social groups to get equitable access. Even within households, male members are often in control of decision making. Even when the household has access to clean lighting, it has often limited access, for example, with solar lanterns. In these cases, who gets to use the lantern, at what time, and for what purposes is often dictated by unequal gender relations. These are some of the questions that we are thinking about in the project. Of course, the project itself doesn't take shape in isolation. We need to think about the institutional context, like the policy measures in place, the government bodies that are active, among other things. But before all this happens, we need to think about the design.
Technology design is always ethically laden. The choices designers make impact people for better or worse. And design always embodies some vision of the good life. For example, a rural Spark has designed an energy router with 16 USB ports. So you can charge 16 devices, lamps or mobile phones, for example. And this design suggests that rather than keeping this energy just for yourself, you should share it. Of course, you can take ethics into account in your design, but people still have to accept it. The gold standard is deliberation. You sit around the table and you talk about the technology. Of course, it's very difficult to do if you're Dutch designers and you're working in rural India. So what some companies do is put their prototypes out there as fast as possible and see how people respond to that. It works for those companies, but is it also just and inclusive? That's what I aim to find out.
Well, the issue of energy poverty is not going to be solved in a single day. And this is why we focus on long-term studies, which helps us to reflect not only on technical issues, but also on ethical ones, also on sociological ones. And this helps us to actually redesign the technology. But the project is based here in Eindhoven University of Technology. And in India, we work together with Terry University, based in Delhi. The two partners from the industry sector are PRE, Power Research Electronics, and Rural Spark. PRE develops the technology, and Rural Spark commercializes and implements the technology in India. But in the next 4 years, we will work closely with all involved partners. We'll go to the villages, do lots of field work, we will live there, and we do all this in order to find solutions which benefits the people most.
Well, so this was the idea that I wanted to give. And I have chosen these videos basically because I wanted to show you the problems that are specific to the Indian context and how people are making use of IoT to solve these problems. So since our country is an underdeveloped country, we have a lot of problems that are not directly relatable to the more developed nations. So our technology should be such that it should cater to the problems of our country. So that is the reason why I introduced you to the application of smart grid, because I believe that this is going to be one of the major sectors which would be requiring or which would be used in the upcoming years and which will be required for India. Okay, the third application which people are really interested in is the healthcare. Okay, we all know and we have been using these wearables which you see on the right hand side. Okay, so these are different gadgets that you wear or you put on your body, and that actually captures some information of your vital statistics, some medical, some clinical statistics which you are required, which is required, and then based on that, the health experts make some assumption that this is possibly the state of the person is, and accordingly prescribe you with some medications or some advice. So this is overall the most abundant use of IoT in healthcare. So as you see, there are a lot of wearables that have been developed over the years, whether it is smart watches, which are the most common. We have the headbands, then we have the biomedical shoes, then smart garments, eyewear to assist sleep, skin patches. So all these are primarily different gadgets that you wear for capturing different clinical parameters, and making use of that, you take different decisions. So this is mainly the use of Internet of Things in healthcare. Okay, the fourth application that is majorly used, or that majorly uses IoT, is industry. So we have, as you see on the right hand side, the figure gives you the idea of the share of IoT usage in different sectors. And if you look at on the right hand side here, you see the industrial products, it's about 26%. After that comes the electronics and high technology industry, which is about 12%. We have automobiles sector, which is also using about 12%. So then we have software. So in and about 26, 38, it's like about, what, 50% of the entire requirement is in industry. And as you see, we are heading towards industry 4.0. What is that? Well, that is nothing but a way to tell that what is the current state of industry today. If you look at the industrial revolution, you will find that it all started in the 18th century, and you all know about that. How the industrial revolution has changed the world since it came up. So what was the industrial revolution all about? It was using different mechanical production. So instead of laborers, you make use of machines to help the laborers in producing some items. And that eventually, equipment which was using steam and water, and that eventually led to huge increase in production. So that is what we call the industry 1.0. Then came the 19th century, and when we moved towards 2.0, and where the mass production assembly lines were required. Okay, so now you started making use of more sophisticated machines, and instead of manual labor, you could create assembly lines. So that is, one after the other, things would be coming out. You have a set pattern of creating things, and then they would come up. Then came the 20th century, and that introduced, we call it the industry 3.0. And this is the era where you started using automated production, right? So you started bringing in robots, and robots were now were used for production. So instead of humans taking part in that, majority of the work was done by robots, and that improved the production a lot. But something that was missing still was intelligence. That is, if I am producing something, what is the extent of production that I should have? Or how can I improve my production depending on the demand, right? So if somehow we could have that amount of information, maybe we can orient our production in that way. And for that, we needed some mechanism to give us or to capture that data. And that is what we called the intelligent production, where you make use of IoT to capture that information. And from that data, you extract useful information that would help in production. And that is the reason why industries today are primarily relying on IoT or ICT technology. Okay, so this is again one of the key areas of IoT usage. And finally, we have smart agriculture, which is again something that people are making use of. And again, I would like to show you a video which will give you the picture of how this concept called smart agriculture can help our farmers. So what the idea is that if you are going to, agriculture is something which is the backbone of India. About 70% of people are still relying on agriculture. So it's time for us to improve the living of these farmers and to include technology to help them in their production. And one way is to have different kinds of gadgets that would be capturing different kind of parameters and providing that information, which would help them extract some meaningful information after doing some analytics and provide that information to the farmers that this is what you should do and this is what you should not do. Let us again have a look at a video, which is again, I would like to show you something that came up. It's a project of Infosys, and have a look.
The agribusiness industry today faces several challenges, such as increasing demand for food, stagnant production, and shrinking resources. However, Infosys believes that rapid advancements in technology can effectively overcome these challenges. The Infosys Smart Agriculture Solution. It provides analytics-driven insights to farmers and agribusiness companies across the value chain. The solution has been developed by harnessing our agro-domain expertise and competency in IoT and big data analytics in collaboration with agriculture universities for expert inputs and concept validation. Here's how John, a farmer, uses the Infosys Smart Agriculture Solution to make decisions at his farm in the upcoming season. John uses the crop and variety selection capability to select a crop. This feature takes into consideration the agroecological zone of John's field and recommends a suitable crop. After selecting the crop, which is corn in John's case, the solution helps him select a suitable variety according to his preference. Once the crop and variety is selected, and he assigns it to a field, the fertilizer recommendation feature recommends an optimal fertilizer combination by considering the nutrient status of the soil. The applications also allow John to schedule the date of sowing. The next important farm management activity that John must deal with is irrigation. To demonstrate this capability, let us use the model farm Infosys has set up at its campus in Hyderabad, India, to experiment, demonstrate, and validate the capabilities of the Infosys Smart Agriculture Solution. The real-time remote irrigation capability analyzes soil moisture data, crop growth stage, and weather data to automatically schedule irrigation for the field. The schedule is displayed on the dashboard, with an option to override the system's action. The application calculates the amount of water applied to the field in the current irrigation schedule and keeps a record of the historical irrigation data. Crop stress in the form of pest infestation, diseases, or weeds pose a major threat to productivity. From the images captured using smartphones or agri-specific drones fitted with NIR and RGB cameras, the solution identifies the cause for crop stress and recommends corrective action to John. This is done through image processing. Here you can see the drone flying over the field in a preset path, capturing images. Post-harvest, the solution offers smart warehousing capability, which delivers regular updates on the storage of the grain based on grain temperature and grain moisture data. This enables John to take proactive action to control pest harvest losses. The solution's sustainability assessment feature records the impact of the crop on global warming, water productivity for the crop, and crop diversity values for the field. This facilitates the sustainability assessment of the field. Apart from farmers, the solution can also enable the field representatives of the agribusiness companies to enhance engagement with farmers. The field representatives can help farmers in the decision-making, promote right products, and increase sales leads. The Infosys Smart Agriculture solution uses algorithms and machine learning techniques to process real-time data captured from the field using IoT devices, in combination with standard reference data, agroecological data, weather data, image repository, FMS, and third-party data to deliver actionable and timely insights to John. Built on an architecture that is modular, scalable, and customizable as per the client's needs, the solution is completely mobile-enabled. This is how we help our agribusiness clients transform to become a live enterprise.
Well, I hope you have now a clear understanding of what and how we can use IoT to bring about smart agriculture. Right? Okay. Let's proceed towards the last one. In fact, there are lots of them, but just the most popular and the one that we are now going to talk about is smart city. Well, this is also a very talked about topic, right? Many people are talking about we are going to make the city smart. So what exactly do you mean by making a city smart? Well, if you look at the idea behind making a city smart is to make the services smart. What do you have in a city? The primary thing that you are looking at is the services that are provided through different municipalities. They include traffic management, air quality management, public safety, parking, lighting, and waste collection. That is overall the basic idea behind the different services that one wants from a city. Now, all these services are currently provided through humans, right? And obviously, you know that in India, with the lot of socio-economic problems, these services are often not delivered to the extent we want them. Traffic management, we all know the amount of hassle that we have while handling traffic. Air quality, we keep on hearing about this in the news. Then we have public safety, parking. The moment you have a holiday season or some kind of a weekend, you know the amount of problem that we have in parking. Majority of lights, the different street lights that we have, many of them don't work, and it takes days before they are repaired. The people who are supposed to maintain them are not aware that they are not working correctly. And finally, we have the smart waste collection, where all the garbage lies, the litters and all are lying on the streets, and there's no one to pick them up. Well, can we understand that things will not change in one day, but how can technology be acting as a supplement to the different service providers so that they at least can be notified that there's something which has to be done? This is the idea behind smart city, right? And one of the applications that we have in smart city is the smart street lights. As you see in the picture, there are 5 street lights which are shown here, and each street light that you see is a smart street light. What do you mean by smart? It means they have some kind of a sensing element. As you see here, this is a light sensor. This light sensor will be gathering the information and accordingly sending this information to the mobile, to the next street light. Say, for example, there are no vehicle on the road. There is no reason why this particular light should glow. They should be turned off. And whenever a particular vehicle approaches or some pedestrian approaches, they should glow. So this is an intelligent way of, conserving energy and allowing it on demand. This is one of the application areas. And we at our lab at IIIT Allahabad are also working on a project. In fact, we were working on a project. And one of the projects that we are working on is this smart street light. The idea behind this project was to have energy saving. This is number one. As I already told you, majority of the lights that are installed, they keep glowing even in daylight, or they are remaining off and nobody cares about their repair because they are not aware that some street light is turned off. So what we intended is to give easy and prompt maintenance. You would automatically notify in case of a fault. And third is, we'll give a scalable solution that our solution can be applied to any kind of street lights. And additionally, if we are using some kind of a connectivity, we would be making use of those to deliver some kind of an internet services like some educational content, some data source, etc. So this is what our plan was. We developed a prototype. Your seniors worked with me, and we developed a prototype where we could control the intensity of this particular device. I'll show you the the first stage of this project that we had, and where we actually worked on this. I think I need to show you here. Is it visible? Is it visible, this PDF?
Yes, sir.
Yes, sir. Okay. Please. Okay. I think just a minute. I'll show you on a different. It's a very small application which we. Okay, so what you see here is an LED light, okay, and this LED light is controlled by a device which is a Raspberry Pi, and we have coded it, and there's a sensor which is there. So what we are doing is, now we are, okay, so the idea is when the environment of this light is completely dark, okay, it's glowing with its full intensity. Now we have turned on a torch, and which means that the surrounding light improves, which is, let's say, equivalent to daylight. Now the intensity of this light should dim. It should turn off. So this is what our intention was. So our intention was to adjust the intensity of a light depending on the intensity of the surrounding. If there are a lot of light in and around a particular street light, there is no reason that the street light should glow. Say, for example, if the street light is installed in around a mall or something like this, there is already too much of light. There is no reason why that street light should be turned on with full intensity. Can we reduce it? So this will save a lot of energy. And if it goes wrong, immediately you can send a notification. So this is what the idea was. Okay, so here are a few other application areas. As you see, it ranges from marine applications to GPS. The RFID tags that are put at around the collar of animals. So here is to just locate this particular animal. Very useful in case of wildlife sanctuary, where you would like to locate a particular animal. So you just wrap around an RFID tag, and wherever that particular animal moves, that information is provided to the administrator of that wildlife sanctuary. Then we have in the forest department, where you can have a track of unlawful activities such as cutting of trees. If you don't want them, you can put a tag, and then anything goes wrong, like people are cutting trees or all, it can be notified, so you can protect them. Then as you see, there are marine applications where you will be able to find out different see what the life, the marine life. So these are different kinds of applications. Wherever you want some data to be captured, and based on that you want to make some decision or do something, you can make use of IoT. Okay, so let's have a look at how the trend is, where, as you see, the manufacturing industry is using 22% of IoT. Transportation. Okay, so today we have the self-driving cars, or even cars with, today, as people say, that cars today or automobiles are more of electronics than mechanical. Rather, they're called mechatronics. So where it's a vehicle fitted with sensors which captures data, and based on that you decide what to do, whether it is anti-braking system, or your your temperature, maintaining the temperature within your vehicle, or let's say the information about the fuel. So all this is today IoT based, and we are moving towards a self-driving car, which is again and one step ahead of IoT usage. Energy sector, as I already told you, a lot of things are happening in the energy sector regarding IoT. Retail business, you're opening up retail shops where you would like to find out what are the different devices that I should keep, where they should be kept, etc. All this is there. Cities, healthcare, agriculture, building, all this is the different application areas and their usage, but this goes on. Okay, right. So what exactly have we understood from this? It's about, currently the situation is, you have a device, you have an app, and the user is making use of this app to control this device, and they are independent. The user is using this app to control. It's like you are using your TV remote to control your TV. Okay, you are using your TV, your mobile phone to control your electrical appliance. And this is the current situation that we have, and this is Internet of Things. But we should actually move towards Internet of Things, which is like the devices would also be connecting among themselves. And I'll show you today something called social IoT, where one device would be as if communicating to another device, very similar to how we people communicate. When you communicate, when you create your groups, say for example in Facebook or Instagram or whatever, what you do is you try to find out people whom you know, and you try to form groups so that you can interact with them. Can we have similar things done for the devices, so that these devices can interact and help the user who's using all of them? We'll talk about that later. Okay, so any questions so far? Are you okay with this? Okay. Now let's, as I told you, if we are going to study a subject, we should know the history of that. So what is the first IoT device that was invented? It's RFID. Many of you may not know that, but it is actually the device that was used in World War II to identify between aircrafts which are of friends and of foe. So the British used this to identify their aircrafts and the enemy aircrafts. So this is the first IoT device that was used in 1940s during the World War II. Later on in 1960, RFID was used for monitoring nuclear and other hazardous material, and the first RFID companies were found during this era, 1960. Okay. In 1973, Mario Cadullo received the first US patent for an active RFID tag. So far in this area, it was all about passive. Okay. And here we had an active RFID tag where you could actually identify a device. So passive means is just, it just is a reader, right? It cannot generate anything. But here we had an RFID that could generate, and that is called active RFID. We'll talk about that later on when I'll talk about sensors and all. So in 1980, you have formally the RFID research started, how to improve that. And gradually RFID was brought into consumer electronics and people started using that from 1990. And the ultra high frequency reader was invented. And as you see in this picture, it was used basically for shipments. And Walmart started their RFID program. So the basic technology behind RFID is, it's a simple way. You have an RFID, which is a device. It's an electromagnetic device that has, it's called an RFID tag, and it generates electromagnetic signals through some antenna. And there's a reader that captures those signals and stores that to the database. Well, if this database is accessed by some application or at some storage, then you get to know what data has been stored from this RFID and you can make some decisions. So this is what it used to be, right? Okay. Then this is overall the picture and the progression of IoT. We started off with machine to machine in 1970s. And the first thing that came up was this Coke machine. So this is the, we can say, the first internet-driven device in 1982, where Carnegie Mellon installed their Coke machine, which was internet controlled. And here we have the internet toaster, which was developed in 1990, which was controlled again by through internet. Trojan room coffee pot, the first webcam, all this was happening around that same time in the early 90s. So let's quickly have a look at how things progressed. In 1980s, it was basically a centralized server. You have every data that was obtained was at one place. Okay, we call that the server space. During the movement during 1990s, machine-to-machine interaction started, where the first cellular module, first GPS network, and IPv6 was introduced, which increased the amount of addresses that could be generated or assigned to a device from 32 to 128. So with only 32 addresses, 32-bit address, the number of addresses that can be generated was 2 to the power 32. And very quickly you would run out of addresses. But if you increase that to 128, the total number of addresses is 2 to the power 128. That is sufficient to handle all kind of devices. If you would like to identify that through a unique number, addresses can be allocated. So IPv6 had to be there. So Kevin Ashton of MIT first coined the term IoT in 1999. Okay. So by 2000 to 2010, gradually the data storage moved from a central server to a regional server, which is located close to the data server subnet. Okay. LG announces the first smart fridge. First iPhone released in 2007, 2008, the first international conference on IoT, and people started recognizing that, okay, now this is a topic, and now there should be research which should be devoted to this particular thing. It's not just a fun stuff that you are, having a toaster or a vending machine. No, now IoT has increased its boundary, and now it's time for us to do some serious research. So there was the first international conference which was held in 2008, as you see. In 2009, Google started testing self-driving cars, and today we have all others who are joining the bandwagon. Tesla has already earned a name in this respect. And since 2010, IoT has moved in leaps and bounds, and we are gradually moving towards edge computing. This is one very, very interesting research problem that we have. And the problem is that if you are using an IoT-based system, you know that the devices that are capturing the data are low resource devices. They have to be sent to the cloud. But the moment you send the data to the cloud, there is a latency in this data. So the people started thinking, can we move this computation not to the cloud, but to the place where the data is captured? And these are called edge devices. So the computing that is done at that end, at the place where the data is captured, that is called edge computing. So here you see with this idea, in 2013, we have Google Glass released, Amazon releases Echo, and GM, Uber, Tesla are all started testing self-driving cars, and IoT continues to grow. So this is the situation that we have today. IoT is growing. Well, so after all this study, what is the basic idea of IoT? IoT basic idea is that you have some environment. From the environment, you capture some information through something called sensors. You think sensors to be like your eyes, nose, ear, tongue. We call these as our sensory organs. Why? Because they capture some physical information. Through eyes, we see, we view some objects. Through nose, we smell something. Through ears, we hear. So same thing with sensors. If you are having an environment which is a physical world, you need some mechanism through which you will be capturing those information of the physical world. They are your sensors. And the sensors will collect data and will pass it on to some kind of a processing element here that will be processing the data. They are called hardwares, embedded hardwares, the computing unit. Together, often these two are called devices. These two are often called devices, the hardware and this. So this is the edge device. Now, once this hardware has collected the data, it's time for that to forward it to the internet. Why? Because in the internet, or maybe somewhere sitting here, is some kind of an infrastructure which is going to collect that data and do some analytics or some decision making on that, which we call the cloud. So it passes this, makes use of internet to do that, or it passes this information to the cloud, to the people. And what will people do? People will take some decision. What decision? To turn on or off something, say actuators. So this is basically the simplistic view of IoT. Let's look at this diagram here. There are two sensors. The sensors, they capture the data and they send this data to the embedded hardware. This is a very low cost, low power hardware, which in turn forwards it to a more resourceful environment, which is the cloud. Cloud is an infrastructure maintained by a third party, say Microsoft, Azure, Microsoft, or Amazon or Google. They are maintaining a more resource system, lot of power, lot of computing power, lot of storage. So they get the data from this embedded hardware. They collect this data, and they are sufficient to run very sophisticated algorithms here. They run the algorithms, they give you the output of this algorithm, and then they send it to another device. Now this algorithm, this is called the end device, which can be your mobile. Now this mobile will be able to get this data through some services, which can be an application, some app or whatever. And by this, you can make use of some control circuitry, making use of some embedded hardware, and you can turn on or off that particular AC. Okay, that is the actuator. Look, so many things are involved. One is capturing the data, processing that, forwarding it to a more sophisticated environment. There the analytics is done. Data results is sent back to another device that captures that, sends it to the control circuitry, and from there it turns off the device. Well, so this is again a view of your IoT ecosystem where you see we have entities or individuals. You have let's go bottom up, right? Now at the bottom is the different devices. And when I say devices, I mean sensors as well as some processing units. Look at this. We have, say, on the right hand side, a robot, okay, harvesting arm, along with a device that is connected, this part. What you see here is it's a standalone non-IP enabled. It's a standalone device. It does not have any internet connectivity. It's just a device. But that gets connected to or is controlled through some device which is connected to another communicating device, which is called gateway. Well, what is a gateway? It's an aggregator. It collects the data from a lot of nodes. Nodes are the sensor and the device together. I call it node. Let's look at this. This is a node. Okay, you have a lot of collection of sensors that is gathering the data. Each one of them has a device which is a computing unit, a very low cost processor. And that is forwarding the data to this intermediate device called gateway that is collecting this data, aggregating. And this in turn has an IP address. And this is identifiable in the internet. This connects to the internet, and this in turn is connected to a more resourceful system, which is called the cloud. What do you have in a cloud? Well, you have different storage elements, which are nothing but servers or server network. What do you store in that? You have a database. What do you collect in the database? The data that you gather from these nodes. So these nodes, they give you different data. This is moved to the gateway into this database. So the database is required in the cloud. You have a specific organization of data. Who wants this data? The users want the data. How will the users get this data? They will make use of some applications to get this data. So the users will actually interact with this cloud to get the data by some applications. So the users are making use of some applications to get this data, and the data is provided through this to the cloud where it is stored. Now, once the user gets the data, it is up to the user to decide whether I would just be happy with knowing the data or I will do something with the data. If you want to do something with the data, that is, you send back some signals back via the cloud to this device, you call it actuation. If you don't want, well, I just want to see the data. Fine. Suppose there are sensors deployed on different meters, the energy meters, and that is giving you different energy readings. And you as a user or maybe the energy supplier is simply looking at the energy consumption of a particular household and is saying, okay, this is the state of that particular household. It just wants to see, doesn't interfere in controlling anything, but there can be control as well. So this is the IoT ecosystem for you. So if we can look at this IoT ecosystem, we can see that it actually is a 4-layered architecture. The last layer, the bottom layer, is called the device layer, which consists of devices, and devices means sensors plus the microcontrollers. We have gateways which aggregate, or we can say this is the node, which collects the data from all these nodes and forwards it to the upper layers. What do you have in the upper layer? In the upper layer means the layers that are required for providing the network connectivity. Just try to compare this with the TCP/IP stack. All of you must have taken a networking course, the OSI model or the TCP/IP stack. Just try to compare this and you will find that very similar to how we have the physical layer and the data link layer. Okay. On top of that, we have, what is the layer on top of that? The physical layer, the data link layer. On top of that, what did we have? Anyone? What is the layer on top of these two layers? Please respond, class. No? Okay, so network layer, the transport layer, right? The application layer. Are you not aware of this? I've forgotten. Well, so there must be some kind of mechanism through which your data that you have gathered at the gateway has to be provided to the cloud. So what is the networking capabilities, or what is the network, the requirements of the network that should be taken into account so that the data can be transferred? Okay, because there's a communication that needs to be there, isn't it? From the device to the cloud, from the sensor to the device. So all this has to be data transfer. So the communication has to be established. So how can you, what is the new requirement for that? That is taken care in the networking layer. On top of that sits the application layer. Okay, sorry, the service layer that is going to provide you these services. Say, for example, the user requires some data from the database. How will it request? What kind of services will you be providing? The web services, the file transfer services, all these have to be provided. There will be some generic support and there will be some specific depending on the application. I need to transfer data between the user and the system. How will I do that? And finally, on top of that sits the application through which you will be making use of the services. So the web service that I'm going to provide, how will the user request this web service? It will be through an app. So the app user will be building or will be designing, and this app will request for a web service. Maybe the web service requires some data to be fetched from a database. Well, but for that, you need to have this layered wise approach, very similar to how we have the TCP/IP stack in case of connectivity of computers. So this is the 4-layered IoT architecture. IoT architecture can be represented as a 3-layered architecture, 4-layered architecture. Some split this application into 2 halves. They call it 5-layered architecture. So there are different layered architectures that have been proposed. Okay. So the question is, why is IoT popular now? Okay. Now there are a few reasons why IoT has become popular. The first and the foremost is things have become miniaturized. As you see, the different sensors that we are using, that we have seen so far, they have become so small that you can put them in a wearable device as small as a ring or maybe a button. It is of that form factor, so small. Because of this miniaturization, and this is the improvement in the VLSI technology, subsequent to this, you have the mechanical parts today can also be fabricated along with semiconductor components. Say, for example, accelerometer, gyroscope, which measures the movement, the tilt. All these devices, micro electromechanical devices, electrical as well as mechanical devices, they can be fabricated. And they can be fabricated of the order of few micrometers or nanometers. So small that you can fit them in very, very small form factor devices. Pen, a button of this order. That is one of the reasons why so huge usage of these sensors. Well, it is not only that, these sensors today are very, very cheap. You get these sensors for the cost of, let's say, 50 rupees or 100 rupees. They're so cheap today. And that is one of the reasons why people are making use of that. Second, widespread adoption of intellectual properties. What do we mean by that? It means that you already have built-in things. You want to build your own system, you use the already created things from the library. Say, for example, there's already something called a digital device which is already created. Somebody wants to create that. It simply takes use of this and builds its own system. This is called off-the-shelf design. It's already ready-made, which is there. You simply take that, plug it, and build your own system. You don't have to make everything from scratch. So they are called intellectual properties or IP cores, which we usually call them. They are available today. Then we have computing economics. System on chip. Everything is on one single chip, whether it is a processor, memory, GPIO, everything today is on one single chip. So you don't have to have a complete system like a computer. You get it within a size of, one, maybe a postcard. This is the size of your entire system, which consists of a computing unit, the memory, the connectivity, the IO devices, all are of this order, so small. Then we have data analytics. Yes, this is one of the very, very dominant domains that we have. You now have sophisticated algorithms, different models, machine learning, deep learning models that very quickly extract meaningful information from the data. Fast connectivity. We have moved from 2G to 3G, 4G, and today we are moving into the 5G era. So fast connectivity that transfer of data from a device to a cloud or from a device to a device now happens in millionth of a second. So with that huge connectivity, it's very quick to send the data from one place to the other. Then we have the rise of cloud computing. You have third-party infrastructure that is providing you things on rent. Okay, you don't have those infrastructure. Okay, we will provide you. You have to pay that. So see, IoT is not something that is very, very fancy. Transducers, processors, network was always there in 60s, 70s, and 80s. What has happened that it has become so popular today? It is because of these reasons. It is because of these reasons that they have become popular. Things have become smaller, things have become faster, cheaper, fast connectivity, and that is the reason why you see things have become, IoT has become so popular. Because sensors were already there, network was already there. The technology that you are using is not something new, but the way in which we are trying to use, that has changed everything. It has found immense application. I've already shown you a lot of that. Look at the landscape, the IoT startup landscape. About 1,200 plus companies have started in June 2021. They have jumped into different IoT related tasks, whether it is software related to analytics, whether it is platform, security, database, sensors, IoT hardware, IoT connectivity. They are handling connectivity related problems, services, IoT development, or a complete device. So this is, it is showing that so many of startups have started. It's one of the indication that it is really picking up. It has picked up and it is growing. So it is going to stay for the next few years. Okay. So I'll end up today's lecture with this summarization that we have done. So what are we going to learn in this course? Now that we have got an idea of what exactly you have, what is IoT all about? how IoT is transforming our lives. Our plan in this course is to give you an overall technical knowledge of the knowledge of different technologies that are involved in IoT, both from a theoretical point of view as well as from an implementation point of view. So module 1 and module 2 will be covered in the first component, and we are going to primarily focus on the fundamentals initially. I'll talk about architecture, the different elements of IoT, which we call the enabling technologies. We'll see different sensors, actuators, processing elements, different communication modules. And we'll also do some hands-on experiments using different IoT platforms. Raspberry Pi, Arduino, primarily Raspberry Pi. But for using Raspberry Pi, you would be requiring the knowledge of Python, which we will be covering in the lab classes. So we'll primarily be focusing on some Python programming for handling Raspberry Pi. This will be our first lab. We'll show you different tutorials. We'll have some tutorials on how do you use Raspberry Pi to gather some data from a sensor. We'll give you different sensors and show you how you can use sensors to capture data. From the data that we are going to capture, we'll send it to the internet. We'll make use of different cloud-based platforms like ThinkSpeak, and we'll see how we can do some analytics and get some information. And at the same time, we'll also be actuating something from the data that we have stored. In module 2, we will talk about different communication technologies, which will involve device-to-device communication, device-to-gateway, device-to-cloud. We will talk about different communication technologies in the link layer, the network layer, the transport layer, and finally in the application layer. We will be focusing mainly on these two technologies, MQTT and co-op. We'll also be having some practical sessions on them. Module 3 and module 4 will be covered in this C2 component, which will be idea of cloud computing, which is again a very topic that should be well understood, and it's very high demand even for your placements. So cloud computing is something that we're going to talk about. I'll show you different models. We'll talk about software-defined networking, and we'll introduce you a concept of social Internet of Things, a very, very interesting topic. We'll use some hands-on session on ThinkSpeak in Google Cloud. Module 4 will be mainly on analytics. We'll talk about different machine learning models, focusing towards big data analytics. We'll also be talking about two very interesting concepts, Hadoop and MapReduce. It's a technique to solve the big data problem. And module 5, the last one, will be some advanced topics, which is mainly to guide you towards the different problems that we have, different advanced topics which involve fault tolerance, IoT security, challenges, and the different research problems. Here are a few resources that we have. The first two are the two textbooks that I will be following. I will be following this for implementation and for the critical concepts. And I'll also be covering, I'll be taking up some articles from these two, mainly this one. This is the web profile. This is you all know about that. Go to this and search for the teaching assignments of mine and where you will be finding them. Okay, so with this, we come to the end of today's lecture.